Welcome to geometry. Our first lesson here is going to be a review/introduction to some geometry tools that we use. First thing that we're going to talk about today is a compass. Now, a compass is just simply an instrument used for drawing circles or arcs, and you have probably done that before. If you have ever seen a war movie or a pirate movie where they're taking a compass and walking it across a map, that is known as a divider, and it is used to measure distances. Now, that is what we're going to be doing a lot of with our compasses. Now, you may think of distances as centimeters or feet or kilometers, but the unit of measurement on a distance is arbitrary. We all decide on one unit to use. That's why we label them, and that's what's given. The thing about a compass, using a compass to measure distances, that's different than, say, a ruler, is if we have a compass, you have a starting point, and let's say you're measuring with your ruler. You can measure this distance with a ruler. But now the thing about using a compass is this becomes a radius because a compass is used to draw circles. Now, if we take this radius, we put the pointy part on our starting point here, and then our compass can measure this distance, but it can measure the distance in every direction. So not only do we know how far it is from our center, we'll call it C here, to the right, but we know how far it is to here, and how far it is to here, and how far it is to here, and how far it is to here. And all of these are the same distance. This is just a radius. So a compass is used to measure a distance, and it can measure that distance in any direction from the starting point, which makes it very, very special and very, very useful. Next is a straight edge, and it is used for drawing straight lines. Now, you probably look at this and say, well, that's just a ruler. Now, if you have the equally spaced markings, then yes, it does become a ruler. But we are going to be using our compass to measure these given distances, as opposed to trying to get our ruler to do it, because the compass has a greater variety of how it can measure those distances. Next is one you should be familiar with, the protractor. It is used for measuring angles. Now, you know that when you put your protractor on your angle, there's a spot here, usually a little hole or a marking of some sort, that goes on the center of your angle. And then you have two sets of numbers for the most part. The bottom set of numbers is for angles that open to the right. So you put your vertex of your angle in that little center spot, and then you line up your angle here, and notice that inside here we have a 0 on our inside set of numbers. Right there is 0. And this is for angles that open this direction. So we are measuring this angle right here. And we go up, and it would be 110 degrees for this one. The upper set of numbers is used to measure angles that open to the left. So we would still put our vertex on this middle point, and we would line up one of the sides of our angle this way, and there would be 0. This is for angles that open this way. So we would be measuring this angle. A coordinate plane, you know from, I'm sure, many of your previous math classes. This is simply a way to describe every point in two-dimensional space. And we use our two coordinates, x and y. They are two perpendicular axes. Perpendicular is good. What does that mean? That's right, right angle. Perpendicular axes, and they intersect each other at the origin. And we usually label them x and y. And then the position of any point in two-dimensional space is simply an ordered pair. And you know these as your XY ordered pair. And that indicates the distance from the origin along your axes. So if we were looking at point -2, 3, that's our x coordinate and our y coordinate, and I always remember those because they're alphabetic, we would move -2 on our x-axis to get there, and then we would move +3 on our y-axis. So this would be the point -2, 3. Simply describes the direction and distance that you move on essentially here what are number lines. You have a number line on the x-axis, a number line on the y-axis, and it allows us to move a set distance in those directions. Notation. This is hugely important here for geometry. We are going to be using notation, and you need to be able to use it correctly. Some of these you may have seen, some of them may be new. There's more than this, and you have a handout on that, but these are the most used, most frequently used that we will see regularly. So we have things like angle, degree, perpendicular, right angle, parallel. This is a big one here. Congruent. What does congruent mean? Congruent means they are the same thing. Similar. Congruent segments we mark with lines. That tells us they have the same measurement. Congruent angles, over here, I'm moving to the right, are marked with little arcs on them like that. That means they have the same measurement. When we are talking about figures, we have, for example here, line AB. Notice that it has a little line above it, 2 arrows on it because it's a line. Ray AB, 1 arrow on it because it's a ray. Segment AB, no arrows because it's a segment. We have, I'm skipping one here, triangle ABC, angle ABC. These are all talking about figures. Two that I'm going to have you take special note of here are these two here. The first one has AB, but no notation above it. This is read as length of segment AB. And this is special because it is a number. All of the ones above it are describing the figure that we are looking at. This says length of segment AB. This is length of AB, and you need to read it like that. You don't just read this AB, you read this length of AB, or length AB, I will accept. It is a number. This next one here, measure of angle ABC. Measure, again, is a number. Do you remember when you got into algebra and they started introducing x and y and told you they were numbers? You have all these letters that are now numbers, and you can add x's and you can subtract y's. These are exactly the same. These are numbers. They behave just like every other number does. So when you are reading them, read them properly. And when you are thinking about them, remember they are numbers. They are just as good as the number 3 or the number -5, and they are treated exactly the same way. You can add them and subtract them and do anything you can do to a number. So those are very special. This is the foundation of geometry. We are going to look at point, line, and plane. These are undefined terms, but they create everything else we do. Okay, these are the basic ideas that we use to build the definitions of everything else that we do in geometry. So very important here. A point indicates a location and has no size. It is what we call dimensionless. No length, no width, no depth. We represent a point by a dot. You know how to do this. There's point A, and we name it with a capital letter. So this right here would be read point A. A line is represented by a straight path that extends in opposite directions without end and has no thickness. Without end is important too. Lines go on forever. You know that. That's why we draw arrows on the end. A line contains infinitely many points. We name a line by any 2 points that are on the line. So we have point A and point B here. And then our notation shows our points and has the little line with the 2 arrows on it. That is red line AB. Now, order does not matter with lines. We could also name this line BA, and we would be talking about the same thing. You can also use a single lowercase letter that's italicized. So this could also be line L. All 3 of those are describing exactly the same line. A plane is represented by a flat surface that extends without end and has no thickness. Are you seeing a pattern here? Cool thing about planes is they are made up of infinitely many lines, which means they're also made up of infinitely many points as well. You name a plane by a capital letter. So over here, the only capital letter here that is not associated with a point is P. This would be named plane P. You need to put the word plane in front of it, because otherwise it would be point P. Or using at least 3 points that are in the plane. So we could use these 3 points here in any order. Generally, you go alphabetical. Order will matter later with figures, but we'll get to that. This would be known as plane ABC. So we could name this multiple ways and be talking about the same thing. Some good stuff that goes with this. Points that lie on the same line are collinear. That co prefix means together. If we cooperate, coordinate. So we are together, and linear is simply a line. They are together on the line. Points and lines that lie in the same plane are, you guessed it, coplanar. A very important thought here, all of the points of a line are coplanar. So if you have a line that lies in a plane, all of the points on that line are also in that plane. Pretty easy to think about. Space is the set of all points in 3 dimensions. So we simply take that coordinate plane and think about it being like on the floor, and we have an infinite number of points on that coordinate plane, that XY plane, and then we raise it into the Z direction, and we now have 3 dimensions. And if you start thinking about the world around you as this 3-dimensional coordinate plane with this infinite number of points, you start seeing these geometry ideas around you. You have walls and floors and ceilings, and then any number of other figures within our space here. We'll get to that some more. So let's do a quick review of what we just did. We have our point A. No length, no width, no depth. Now point A gets together with a whole bunch of its little friends, and they all line up, an infinite number of them, and they create a line. So an infinite number of points makes this line. And then our line here gets together with an infinite number of its friends, and they all line up to make a plane. Now, lines in a plane can go that way, they can go that way, they can go that way, they can go any direction. As long as they travel in a straight path, you have an infinite number of lines in your plane. And finally, we are going to look at some definitions. Point, line, and plane are going to be used to give us all of the definitions that we are going to use to describe all of our geometric figures. A segment is simply a part of a line that has two endpoints and all the points in between them. So here's our two endpoints AB, and all of the points that are in between here make up our segment. We name our segment by its two endpoints. So you can see our notation here says segment. Notice there's no arrows on it. It's just a segment AB or segment BA. Order doesn't matter in this one. Now a ray is also a part of a line. It has one endpoint and all of the points of the line on one side of the endpoint. So we have our endpoint here, and then a ray extends out that direction. That's why we put an arrow on a ray. You name the ray by its endpoint and some other point on the ray. So this ray is ray AB because it passes through point B. Now, the order of the points indicates direction. Order matters here. It's worth making a note. Your endpoint is always first. Which takes us to the next thing. Opposite rays are two rays that share the same endpoint and form a line. That's worth some indication there. Form a line. You name opposite rays by the shared endpoint and any other point on each ray. So we have two rays here and they share endpoint C. Our first ray, CA, goes this direction, goes through point A. Our second ray here, CB, goes through point B. So you never switch your notation around. You always start with the shared endpoint. Rays are always named with the endpoint first. This is the first thing we've run into where order matters. So this was a good introduction/review to all of our geometry tools and some of our terms. Again, welcome to geometry.